Another example for a direct proof. If you want to have the or to see the full explanation of a direct proof or how it works, kindly go to my previous video before this. So here we're going to prove this a simple proposition. If x is an even integer, then we have x squared minus x, or rather x squared minus 6x plus 5 is going to be odd. So again, as what we how we write proofs, we're going to start with the word proof here. Usually we do that. It's going to be italicized, or what I'm going to do is I'm going to underline it and put a period at the end. So again, it's a direct proof. So what our outline would be, we're going to write suppose P is true. So this is our P again, and this is our Q over here. So this is a conditional proposition. So we're going to show directly in a straightforward way that if P, then Q happens. So P is in the form of x is an even integer. So suppose x is an even integer. Okay. So therefore, we can say that then, since x is even, we're going to find an argument that will lead us to this form, that x squared minus 6x is going to be odd. So then we can say that x is equal to 2a since it's even for some, or it can be for all a in the integers. So this is, how do we do this? By common practice, we want to put by the definition of an even number, or even integer, shall we have. So if that's the case, x is equal to 2a. We want to prove that x squared minus 6x plus 5 will be in the form of an odd integer. Okay, so we can write that. So we have x squared minus 6x plus 5 is going to be equal to, we let x to be equal to 2a. Therefore, this is going to be equal to 2a squared minus 6 times 2a plus 5. So let's continue this below. Then we have, this becomes 4a squared minus 8, rather, not 8, 12, rather, 12a plus 5. And then we want to put it in a form of an odd integer. Okay, an odd integer. Remember, we want to note here, note that an uh, odd integers is in the form of, sorry, of uh, 2a plus 1 for all a in the integers. Okay, so since we want to have this form here, we want to put a 2 as a coefficient of one term. Okay, and we want a to be something even as complicated as anything. The thing is, whatever this a is, you want to multiply it by 2, and then you were going to add 1 to that. Okay, so what we want to do is, first and foremost, we want to get this 1. Okay, we want to secure this 1. So from here, since we have 5, we will get 1 out of that, which will give us 4a squared minus 12a plus 4 plus 1. Okay, so since 4 plus 1 is 5, so we're just going to get the 1 out of it, to secure that there's a plus 1 as another term. And then what we're going to do is we're going to try to get the 2 from these terms over here until here. Okay, so if we're going to do that, what we have is 2 times the quantity of 2a squared, okay, minus, or rather, not close quantity, minus 6a. We're going to get the 2 out of the 12, and then plus 2 plus 1. Okay, now this form, everybody, is already in the form of 2a plus 1. We will just need to have, we will just let some integer b, it will not for, not fit there. Let b be equal to 2a squared minus 6a plus 2. Then, if that's the case, we have 2 times b plus 1, where b is equal to this for all a in the integers. Okay? Now, if that's the case, so therefore, this x squared minus 6x plus 5 is in the form of 2b plus 1. Okay? Hence, x squared equals, not x squared minus 6x plus 5 is going to be equal to 2b plus 1, where b is equal to 2a squared minus 6a plus 2, which is in the form, shall we say, which is in the form of an odd integer. So therefore, we can now say that x squared minus 6x plus 5 is therefore odd. Therefore, x squared minus 6x plus 5 is odd. And this is the end of proof. Okay, so I'm sorry, there's a note there that clears up the space, but anyways, that's the point. Okay, let me have again review the proof. So suppose x is an integer. Suppose x is an integer right here. So what we did is we want to prove that x squared minus 6x plus 5 is odd directly using a direct proof. So we're supposing that x is an even integer, which is in the form of 2a for some a in the integers, or for all a in the integers. By the definition, this is by the definition of an even number. So we have x squared minus 6x plus 5. We're going to substitute all the excess by 2a, leading us into this certain statement then. So since we want to make it to uh, prove that it's odd, therefore we will end up in this statement, which is in the form of 2a plus 1. So we have let a variable b equal to 2a squared minus 6a plus 2. So hence, this expression here will become this expression here, letting b to be equal to this for all a in the integers. Hence, we have x squared minus 6x plus 5 is equal to 2b plus 1, in which this simply states that this x squared minus 6x plus 5 is equal to this, 2b plus 1, which just signifies that it is in the form of an odd integer. Therefore, we can say that x squared minus 6x plus 5 is indeed odd. And that's the end of our proof. Okay, so that's our direct proof example number 2. I hope you learned something from there, and there will be more that I'll be creating soon. So keep updated. Don't forget to subscribe and hit that bell button, and thank you very much for watching. See ya.